loves to dance, and she was like contemporary dancer also. So please give a warm welcome to Ines Arkap.
No? So every time they put me this microphone I really want to sing Britney Spears, and thank you so much, Diego, for allowing me this today. So yeah. But yeah, enough of Britney. Let's go to core web vitals. So hi, everyone. I'm Ines, and I'm a rage clicker. It all kind of started back in 1995 when my family got a first computer. I was 4 years old, and as you may imagine, a 4-year-old on the 1995 computer, I used it mostly to paint. No, you would just do that black thingy and then fill it in. So yeah, hopefully I'm not the only one that did that. I don't see you. I would do like a raise of hands, but I don't really see your faces or hands. So yeah, I'll just hope there is more people who did that, so I don't feel that old. But after that, as I grew older, I scratched my way into a bit of some games. Dad had these like Civilization and all that games. Didn't really stuck with me. My sister is a gamer of the family. I, however, really loved computers, but to get things done. So as we progressed, and as the first time I used computer to do a school assignment that usually I had to go through a lot of encyclopedia. Again, hopefully someone understands here as well, that pain of going through many of these. I realized how useful this is. So we were going more and more, and other than like being able to use this tool to get things done, I also realized I lived in a tech bubble. So as we were progressing, the technology kept on progressing, and it was faster. So as it went, I was always at the top of the game until the smartphones happened. So smartphones happened, and that was the first time I felt rage. That was the first time I tried to get something done, and I couldn't. It was just so damn slow. And to be honest, I had a feeling that from that moment as well, that whole internet didn't really progress as fast. So technology keeps progressing. However, websites were getting slower. They were getting like sexier and bigger, and there was more technology on it, more frameworks. However, they were slower. And the rage clicker Ines didn't really appreciate that part. Front-end engineer Ines did. So when I finished university, I actually got my first job as a front-end engineer. It was the first time I ever did that. When you finish computer science, electrical engineering, you end up, with your diploma knowing how to solve problems in general way. And I wrote my first piece of JavaScript. I got the job. Yay me. However, I learned everything I knew on the job, and it was so much fun. It was so damn fun, trying out new technology, putting so many things on it. And I guess I was having so much fun not to kind of sync with the raginess, like rage clickiness, to realize that all this stuff I was putting on the website was slowing it down. So as I was just about to drop junior from my title, I had this kind of series of interviews with my senior peers, different colleagues as well. And there was, of course, HTML, JavaScript, CSS1, and then there was a web performance interview, in a way. So I was like, okay, what's that? Let's do it. And it was actually the first time I spent around 2.5 hours with one of my colleagues that I barely knew back then. Later, it became one of my dearest colleagues and mentor, analyzing websites. And I was like, okay, wait. There is something happening here that kind of started connecting these two roles of mine, the role of a web creator and the role of an angry user. And basically, from that moment on, I was stuck with web performance. Okay, how do we optimize it? How do we make it as fast as possible? To be honest, it was so much fun doing this. However, I hit this huge obstacle of no one cared. Like, okay, can we make this faster? Yeah. No. Can we do that? Yeah, we will. So if you've ever been to World of Accessibility, similar thing was happening. And I still remember the moment it changed. So I was on site for this client. I was a front-end lead on that project. And we did everything from scratch. It was awesome. And then the content started coming in. And as you may imagine, it was getting heavier and heavier and more bloated. And there was this thorn in my tie, nice carousel with the many very, very heavy images. So we had back and forths about this carousel for weeks. I would even dare say months. And one day I was talking to some of the stakeholders. I was like, okay, but like, why? Why are we doing this? And they're like, you know what? So we're selling these places, we're making money out of this. And this whole lot of frustration just came out of me saying, but you're losing money with this. Yep, that was the key word, money. The moment I started transferring this into money, people started listening. And, well, that client listened from that on. However, that was only one out of 1 million sites across web. So, as you can see here, I'm a huge Core Web Vitals fan. And this is because the moment Core Web Vitals came, they changed the game. So a few years back, Google introduced the metrics that would put a number on user experience. Yeah? That was like kind of my first reaction, was like, can we really put a number on user experience? Isn't that something that's supposed to be very subjective? And yeah, the more that I thought about it, it kind of made sense. And I was like, okay, a few more, 3-letter acronyms. We love that in web performance. And more metrics, yeah, always good. I like more metrics. However, thinking about it, like, okay, user experience is a lot about psychology and how people perceive this, how people navigate the web. So trying to put a number on it may not be the worst part. And then actually, the best part came. They decided to use it by ranking system. And this was the game changer because ranking, SEO, means money, and that means people listening. One more thing that it did mean as well is people hacking Core Web Vitals. So please don't do that. I'm about to teach you what Core Web Vitals are, how to improve them, so please don't hack them. Use your time better and try to optimize them instead of hacking. So yeah, I cannot ask you to promise me that, but yeah, I'll make sure that you do. So yeah, let's learn about Core Web Vitals. I'm going to ask you a question, and hopefully I see something. So how many of you here are front-end developers? Can you please raise your hands? Okay, good. How many of you do know Core Web Vitals? Okay, less, cool. So Core Web Vitals, as I said, are metrics that are basically putting a number on user experience. So when we have a website, when user navigates to a web page, first thing they want to know is something happening? No? What's up? Like, is there a connection? No, something has to happen. After that, is it useful? Whatever we saw on a page, is this something that we can use? Is this something that we like? And of course, is it usable? Can we interact? There is so many applications these days, not only static website, that we want to interact, we want to buy, we want to reserve, we want to open stuff, find out. It has to be usable. So the 3 metrics Google introduced were to measure loading, visual stability, and interactivity. Largest contentful paint for loading, cumulative layout shift for visual stability, and originally first input delay for interactivity. First input delay, however, became obsolete 2 months ago and replaced by interaction to next paint. So even though we kind of agree already, to completely remove FID out of the picture, I wanted to show you this just because it's changing. So Core Web Vitals are not here to stay as they are. So as we go a bit deeper, I'll show you also a few places where they get upgraded. So as we go, Google accepts feedback, is doing research, and is trying to put the best possible number on user experience, again, even though that's a very, very hard task to do. So how do we measure them? In order to be able to optimize, we need to be able to measure as well. We have two main options, which are field data and lab data. And as you can see here, field data, main purpose is to answer the question if there is any problem. Because you may not have a problem, which means, yeah, you can close your laptop, go home, and yeah, do something else, maybe some gaming. However, if there is a problem, that's where the lab data comes in, which allows us to see how we can fix it. So, field data is real user performance data of all the URLs. How it usually works is that you add a small script to your website. It's usually made by web performance experts, which means it's very lightweight, it's not blocking anything, and it sends data, basically like analytics. Tool sends data about performance back to the tool that, of course, visualizes it. It has limited data because depending on browser's API and data layers, however, also has a big variety of devices, browsers, and connections. Field data tells us how real users perceive the site. And where you can see this data is first and foremost Chrome User Experience Report, or CRUX. So CRUX data is the data that Google got from Chrome users. So this is also the data that's being used for SEO and for actually positioning. Other than that, there are many different tools such as SpeedCurve, RumVision, DebugBear, as well as the bigger players, like Cloudflare has its own, Akamai, etc. So these, again, collect real user data as they're navigating on the site. Lab data is data that basically comes from a simulation. So it's single URL test triggered by a computer. It can emulate an older device, different browser, it can emulate different connections. However, it doesn't show the real state. So a lot of times, for quite a long time, we used only this option. And again, it helped us quite a lot. However, a lot of times we did redundant optimizations because we didn't really know if this is how our users really perceive it. Most of you have probably seen Lighthouse, Web Page Test, my personal favorite. There are dev tools in the browser, as well as some extensions such as Web Vitals and Yellow Lab tools. So one tool that kind of does it both together is Google PageSpeed Insight. Inside there, you can put a URL, and it will give you both. It would give you field data from CRUX, as well as the Lighthouse report. As I already said, so the CRUX data is the data that's actually being taken into consideration for the page ranking and similar. And it's actually how the site behaves. So Core Web Vitals are the ones you should brag about. So there is a lot of people still sharing Lighthouse scores. Please don't do that, because Lighthouse score is not that relevant anymore. It doesn't give a good picture as well of how site behaves because it's a simulated environment. Lighthouse score does also not really correlate well a lot of times with the actual field data. Don't get me wrong, we still do love Lighthouse, and we still use a lot of these notes that it gives you. So definitely use Lighthouse, run it occasionally on the site, see everything it gives you. So also, as you can see here in the corner, it gives you also nice filters for Core Web Vitals. So it gives you also ideas how to improve your Core Web Vitals, which we're gonna go into next. First one I want to address is loading. So LCP, or largest contentful paint, measures the time from when the user initiates the loading until the page's largest image or text block displays on the within the viewport. So we click, and until the image displays. One thing also that has been happening, of course, there was a lot of hacking of this Core Web Vital in particular. And last year, Google changed slightly the algorithm, how they define what LCP is. So now it gets something that's called entropy of the image, which also checks how much data image actually has, because we want contentful paint, not just the paint. We want there's something relevant. There is something that we want to see. So this is, for example, one of the optimizations that's happening over the last few years. So in order to get to the largest contentful paint, there are actually 4 different stages. There is time to first byte, resource load delay, resource load time, and element render delay. Due to the time constraint, I'm definitely not going to go super in-depth into this one. However, there is a great talk by Stella Franco about this, and I'll be happy to share this in order for you to learn more. What I just want to comment here is that, as you can see, there are a few different stages where you can optimize and which can make, let's say, a mess out of this loading. First one is time to first byte, no? Server side. So the moment the first byte comes to the browser, if that one is, for example, more than 2.5 seconds, which we consider to be a good LCP, there's not much you can do on the level of front end, not that much you can do on the level of the browser. So this one, for example, is first one to check for optimizations. Resource load delay and element render delay also both have delay inside. So these are the ones that you would like to get as close to 0 as possible. And of course, time to first byte and resource load time are the ones that depend on the network. So they are going to be there. Resource load delay takes the time from the first byte that comes in to the moment, let's say that image is an LCP, which usually is, it gets discovered inside of the HTML. Then we need some time to download that image, and then we need some time to render that image. So those are 4 stages that it takes to process the full image and display it inside. So knowing that, naturally, these are the few issues that come when it comes to LCP. Slow server response time, slow resource load times, render blocking JavaScript and CSS, as well as the client-side rendering. Server side, as you may imagine, using a CDN, optimizing browser caching, etc. As soon as the bytes can hit that browser, the better. For the assets, similar. We want the resource to be discovered from HTML as soon as possible. So please, please, please don't put the largest contentful paint image inside of the CSS because it will delay it quite a lot. Preloading, high fetch priority, and one also quite interesting thing that I've seen analyzing many sites over the years, no loading lazy on LCP elements. So you wouldn't believe how many pages actually have the lazy load on the LCP element. LCP element needs to be very high priority. It has to be loaded as soon as possible. So if one thing that you're going to check about LCP once you leave this talk is please check this. This could be a huge deal. JavaScript and CSS can have a full talk by themselves. So in order to be able to load as soon as possible, removing especially the parts that are not necessary. So there's so much unused code on the websites that just from removing this, we could speed up the internet drastically. So checking for the amount of unused code, compressing, minifying all of that as well. A lot of times it's not there, even though it kind of should be. And of course, deferring. Once that is done, you can also inline CSS needed for LCP element in order to give it a bit higher priority and to have it as soon as possible. And last but not least is optimizing assets. No? So putting new formats of the images, WebP, AVIF, responsive images. So the smaller the screen sizes, of course, using picture element. And actually something brand new, which Google announced last year on Google I/O, last week in Google I/O is responsive videos. So basically the same way picture tag works, there is now a video tag that can also include a smaller version of the video, which is awesome. And last but not least, don't target or A/B test LCP. Again, it requires, same for discovering it in CSS, it requires JavaScript logic in order to do that. So a lot of times you're going to get, but this allows for a better user experience, not if user never come to the website. No? So this is, again, web performance is a fine balance of fine-tuning the website for all of these. So hopefully, that as well, you can fight that battle and get actually to users to come to the website and then provide the best experience. My favorite one is actually visual stability. So cumulative layout shift is a measure of the largest burst of layout shift scores for every unexpected layout. So basically, when something, an unexpected move happens on a page, it penalizes it. So of course, it gets measured if there was no any input from the user side. This is also one of the changes that happened. So initially, Google was going through every single shift. Of course, that's where the name also came, cumulative layout. So every single shift and reported that. However, throughout some testing and feedback, they realized that it's actually better to split it into small session windows. Again, not super important in order to be able to optimize it, but just as well to see the progression of the metric itself. And how is it getting measured is, so as you can see here, we have a mobile phone, and there is a content box, which is 50% of the viewport. So important thing, if it's out of, like down from the viewport, up from the viewport, if it's not in the viewport, doesn't matter. Only thing that matters is something that is in front of you. So 20% of the viewport gets moved. So for example, in my case, I get so frustrated when this happens when I'm reading something. No, you're going through an article, and 2-3 minutes into it, everything starts shifting as the ads started coming in. So this is a typical example of cumulative layout shift that we would like to avoid. So how much it was moved is the distance fraction. The impact fraction is how much of the screen it affected, and product of these two is actually the number that Google takes into consideration. What causes it is image without dimensions. So while image has to, as you saw already in the LCP, like the progression, it has to be discovered, it has to be downloaded, it has to be rendered. So while all of this is happening, a lot of times there is a space, an empty space, which is good if there is an empty space. If there is no empty space, then the CLS happens. So adding dimensions to images, width and height properties, actually browsers are smart enough to know and actually to take only the aspect ratio out of height and width. So you can put inside of the height and width programmatically the biggest image. So let's say the biggest image that's going to be there is 4,000 times 3,000 pixels. If it's the one for the mobile, it's not going to load that one. It's just going to take this aspect ratio and, of course, as well apply it to the smaller one. Adds, embeds, iframes without dimensions. So this is actually a really tricky one. And it gave me a lot of headache as a developer because we have no idea what's going to come in. A lot of times, as a user, I usually see it on these news websites. You have like the main news, and then up, out of the sudden, a lot of things starts coming, especially whatever you saw last. So yeah. And basically, what we can do there is save some space. So if you don't have an access to the information, how big this incoming ad is going to be, you can always save some space. So let's say the ad's going to be 500 pixels, but you don't know this. If you save 200, you're going to have 300 shift and not 500 shifts. So that's kind of a bit of a workaround. But it would be great if marketing could work with us and tell us what's the actual size. Dynamically injected content, and as well as the web fonts. So when web fonts start coming in, especially with the big web fonts, also a lot of times you can see that kind of flash of unstyled text or just a kind of swap in between the system font and the web font incoming. So for images, as I already said, quite easy. Set the image dimensions and set image aspect ratios. Pre-allocate layout space and leverage BF cache. So small note here. So BF cache, or backward-forward cache, is actually in-memory cache that stores a complete snapshot of the page. So Google introduced that end of 2021, and basically it did a huge improvement for a lot of internet. So it's very nice to see like crux data from that moment, because it was just like kind of a small speed up in like the every data of every website, especially the ones who were eligible. So this is actually the main part of the backward-forward cache, is that it gives you instant help. However, it has to be eligible, the site. So I would encourage you to read a bit about that because it also keeps changing what makes it eligible or ineligible. And on your Chrome developer tools, in application, backward-forward cache, you can see if it's actually eligible or not at this point in time. So we pre-allocated a layout space and we put backward-forward cache. Fonts. So as well, I would say as well, try to keep it like down a notch when it comes to fonts. I've seen websites with like 22 fonts, which I'm not really sure why. So again, talking to developers, I know it's not your responsibility. So a lot of times it comes from designers. So if there's any designers here, please reduce fonts. And if that's not the option, there are options to provide WAV2 files, which are currently the best option of compression, as well as subset web fonts. Subsetting fonts can do a huge thing. So I'm a bit over-optimizer, so on my own personal website, I actually subsetted my fonts. Actually, I have one font, and it has the 9 letters of my name and surname. That's it. So I brought it down from, I don't know, like 200 kilobytes originally to around 4. So of course, this is not something that you can do on an enterprise level. However, subsetting it only to Latin or subsetting it to any characters you need instead of delivering everything can also provide a huge benefit, generally in the loading as well as with this cumulative layout shift when it has to swap the font. And there is also one, I wouldn't call it a hack, but if you use a CSS transform property to animate the move of something, it won't get triggered as a cumulative layout shift. No? So this is also an interesting point to know when you're thinking how to create your site. So basically, when it comes to cumulative layout shift, please save the spaces as well, and again, try to load as few things as possible. And last but not least is interactivity. So 2 months ago, first input delay got replaced by interaction to next pane. Why? So first input delay was basically telling us how long it takes until the user can input something for the first time on the site. And a lot of research showed that actually 90% of the time spent of the site is after the initial load. And this is actually where it became interesting because first metric is something that we kind of consider as a participation medal, like everyone had it quite good usually. And IMP is a tricky one to optimize because a lot of times is about JavaScript. And we know how tricky that one can be. So what it's trying to achieve is good responsiveness. We all know we've been so many times, well, the rage clicker over here, we've been so many times on a website that you click something and nothing happens. This is the worst thing you can do to a user. Like, I really believe so. Because when you actually start clicking and you don't know if you added something to the cart, you don't know if you reserved something, you don't know if the navigation menu is not opening. So there are so many things that can be like janky and not respond. And again, it creates a lot of frustration and rage clickers as well. So to show you as well a bit visually how this difference look like between these metrics is, so we all know as well, browser has one thread, which is overworked, underpaid. There is a great talk about that as well. And it can do only one task at a time. So this is where the problems actually start happening. So JavaScript is running on the main thread, and there is already something visualized. User clicks it. However, as you can see, like the click is in more or less kind of 2/3 of the processing of the tasks. So first, we have to wait for this task to finish because main thread has to be free in order to be able to register that something happened, that we touched something or clicked something or pressed. After that happens, there is a processing time that has to be done as well. No, so depending what you have, there is a lot of times these events also have some analytics data sending attached. They can also go, for example, let's say if we're searching, we also have to do maybe some queries to the outside and similar. So there is a processing time. And of course, there is a presentation delay. So render, paint, and everything the GPU has to do until we have our frame updated. FID was showing us this part. So just this part from when you do something on the website until the website can respond, the thread can respond. IMP covers this whole process, which allows us to understand this much better. Also, IMP goes throughout the whole session. So throughout the session, every single interaction is measured and how much it takes from the interaction until something changes, visually changes on the site. And the biggest one is reported as the IMP. Depending how much there is, a lot of times, so I think if it's over 50, then the outliners get deleted, and then it's only the one from the level, the second largest one. So first part is JavaScript responsibility. Second part is DOM size, which also naturally brings us to what causes a poor IMP. Large JS bundles, long tasks, overworked of the main thread, as well as the large DOM size. So long task, just to also define that very quickly, is a task that blocks the main thread for more than 50 milliseconds. And there is, to be honest, I've seen many of those over the years of analyzing sites. So usually how you can identify them is in the dev tools. There is a performance panel where you can do a lot of fine digging into this. It took me some time to actually get to figure out how to use them. There's also like great resources about that. So when you see this red triangle on top of the task, that you can see here as well. Do I have? I don't have the pointer. That basically indicates the long task. So what we want to do is we first and foremost want to only load the necessary JS. And this is something I've seen a lot, I've fought a lot, because most of my career I've been working with enterprise and with CMS. So a lot of these enterprise move slowly, and CMS in its nature has a lot of different components. So as a developer, I have to create code for these components, but I never know what's going to come on the site. And of course, a few years back, before HTTP 2 came into our lives, we had to create one big bundle, and these are still out there. So this 1 megabyte, I've seen up to 2.5 megabyte of JavaScript bundle, which has such a bad quote coverage, because let's say you're loading this 2.5 megabytes of JavaScript of every single component that can be used inside of the CMS on a site that has header, footer, and maybe text and image. So yeah. Putting JavaScript and CSS into smaller bundles and loading only the necessary ones is something that can already create a huge deal when it comes to loading and as well processing, because every single line of JavaScript that's on the page has to be processed, no matter if it's going to be used or not. Chunking JS to avoid long tasks as well. This is something I'm going to show you also in a few minutes about how to do that. Unloading the main thread, so there is as well, so third-party management kind of go as well together. So you've probably heard about workers. I'm not going to go as well into depth. However, there is possibility to send some of the processing stuff towards the web workers, and they don't have the control over the DOM, so you cannot change anything at the DOM, but if there's any computational stuff that you need to do, consider putting them to the workers. And of course, third parties. So these are also one of that huge thorn in my side. So on the same actually project I was telling you in the beginning, I saw at one point a huge amount of third parties. And that was actually before we started the full redesign. And I think it was around 22. So what I did is I created a sheet and put all of them inside and asked for responsibility. Like, who put this, why, and do you still need it? We end up with the 4. So many of these were legacy that someone installed. So for example, the worst one was Hotjar. It's this one that tracks where the user navigates, clicks, and everything. It's very, very big library. And it's used to test something for few minutes, for maybe a few days, a week or so, and then should be removed. Maybe also segments for part of the audience, not everyone. It was there for 4 years. So this is also a very useful, can be create a sheet of all the third parties, see who is responsible, and actually make people responsible, because a lot of non-technical, let's say like this, non-developers, so marketing, business, content creators, don't know the cost of JavaScript. They know how much money they're going to get if they sell the places in the carousel. However, they don't know how much money this carousel costs in clicks and in performance. That kind of pushes you down as well. And of course, last but not least, reducing DOM size. So there is, every time we need to change something, if the DOM is big, it's going to take much more time, as well as like layout trashing, which is basically when you access to DOM to calculate the position of an element on the DOM. Okay, we still have 5 more minutes, which means I can go into 2 more topics. I would like to show you about IMP, about JavaScript and performance, which is first is one that I'm quite a big fan of, and that's import on interaction pattern. So this is something that I implemented in few projects, and it gives us huge benefits for IMP, and again, as well as loading, because, so as you can see how it works is that you don't put the whole YouTube video player on the page, you put the facade. So you can see the difference in the kilobytes. This one is 540 kilobytes, is the full-blown YouTube player, and facade is 3 kilobytes. So facade means you can basically do a screenshot, that looks like the YouTube video is there, with that play button, and just embed it as a very well compressed and sized image. And of course, attach event listener to it. So when the user clicks on it, then the whole thing starts loading and it adds the JavaScript it needs. So a lot of times, I actually did some research in some previous talks, and a lot of times people don't look videos that much on the website. And the people who do want to watch videos on the website are going to know, are going to expect that it's going to take some time to load. So let's do a small research. How many of you clicked this chat button in the last month? Okay, basically no one. I don't know if there's someone that I don't see, but basically, yeah? Someone? Say yes. Okay, so again, same thing. You can potentially save 245 kilobytes by just creating this icon that will have a listener attached, and when you click it, when someone actually wants to interact with this helpful chat, then everything's going to load. And if you need the functionality, you're going to wait for a few seconds. That's going to be fine. So this is a power of import on interaction pattern. And the last thing I want to show you today is yield to the main thread. So this is how to segment the JavaScript tasks. So a lot of times what we have is this huge JavaScript function that has many smaller ones inside, hopefully. However, when you see this save settings function, and every single one of these, validate, show, spinner, save to database, they're all considered as one tasks. So what we want to do is we want to tell the main thread that these are not the same task. They go in the same order. However, main thread needs an indication that it can kind of breathe in between these tasks. And this is where yielding comes to play. So as you can see here, there is a one long task to save settings for all of these ones. This is how it looks in the Chrome DevTools. And this is how it looks when we actually break it down by yielding. So every time you see this white node that it's kind of new task, this allows main thread to check if there's anyone waiting for it. So to show you more or less how it works, so without yielding, you have a long task, you have input, it renders, and then there is the next queue task. Currently, so there is a scheduler.yield function that's currently in origin trial, so hopefully we will have have it soon and be able to use it soon. And at this point in time, we can emulate this by using set timeout to 0. This is something that will put the task as the next one in the queue. So as you can see, so it's not a hack. Google approves it, so you can use that. You have a chunk. You have an input, render, next queue task, and then the continuation of this chunk that has been done. Yeah? And then, of course, with the schedule yield, it will allow us for more control when it comes. You can actually decide exact moment when you want this task to continue playing. So this is just basics I want to show you just for you to know that this exists. In order to master IMP and all of this, there is the understanding interaction to next paint from actually that Google released also last week on Google I/O. So I did this last year when it was still in kind of GitHub option. It was created by Michael Motzny. It's great. It has very, very hands-on approach, and it kind of shows you how JavaScript works, when these tasks get where, what triggers first. So it's actually a very fun exercise. I did it with my team, and we actually had quite some fun. Well, we're also very, very web performance nerds, so take this into consideration. But yeah, it's very interesting. If you love JavaScript, if you love playing it with it, check this, understanding interaction to next paint, and it's going to explain you this very well. 003, yes. So that's it. That's what I had for you today. So hopefully I did not overwhelm you too much. It's a lot of information, I know, but just wanted to give you a bit of an overview what there is, and that kind of allows you to Google more for the rest. And of course, ask me any questions if you have. Thank you.